In this video, I will show you how to do propensity score matching in R. Before you view it, please make sure that you have watched my propensity score matching video and propensity score example video. I have opened up here the R program in RStudio, and I have already executed the program here. And you can download the program as well as the data from my website and follow along. So this would be an example on how to do propensity score models and treatment evaluation. So if we look at the data, this would be the treatment variable, which is a 0, 1, whether or not the person participated in a treatment program. Age, education, and whether or not a person is married are the independent variables on which we will match. And then real earnings for 78, this is the outcome variable. So based on whether or not people receive treatment, we want to know, has this treatment have had any effect on their real earnings? Afterward, we would also do a difference in differences model. And for that model, we would be using this variable here, real earnings difference, which is the difference before and after the program. So let's go back to the program. And here's how these variables are defined. Treat would be our treatment variable. Then real earnings 78 would be our outcome variable, the one that we want to compare. And the three independent variable, age, education, and married, there with C bind, we're putting them into X. And I will use in one of the graphs later on the age variable, which here I'm calling variable 1. For the difference in differences model, you can use Y, which would be the real earnings difference. That would be the outcome variable. And so you can just remove this sign and rerun the program for the difference in differences model. So this is how the variables are defined, and you could just change the treatment, the outcome, and the independent variables and put one of these in here, and the program should be running for you. So before you continue, also make sure that you have installed the packages matching and RBounds, and then you have put them into the library so that we can use them. We can then calculate descriptive statistics by using the summary command. And here are some of the descriptive statistics. We have 7% of our sample have received treatment. For them, treat would be equal to 1. We have the average earnings here are $20,502. And we have, for age, education, and married, these are the averages that we have. The next thing to do is calculate or estimate the propensity score model. And this is a simple probit model in this case. And we would use the GLM procedure here. And here we would put treatment as the dependent variable, that 0, 1 variable of whether or not you're in the treated or the control group. And X would be our independent variable. For family, we would have binomials, so this would be the probit model, and then data would be my data, and then we would summarize the results. So these are the results that we have here for the propensity score model, and you could go ahead and interpret these in the normal way, the way we interpret probit model results. So people that have higher age, higher education, and are married, they're less likely to be in the treated group. And this is what we can get from this estimation. The purpose of this propensity score model here is not actually to look at these results, but to calculate the propensity scores, or these are the predicted probabilities from this model that we will use later on to match on these variables, on this propensity score. So that's the goal of this propensity score model here. These are the predicted probabilities. So now once we calculate those predicted probabilities for the treated and the control group, then each of the treated observations gets a match from the controlled group, and then we can compare the average treatment effect on the treated. And this would be, you have to specify y, and I because I use the same notation, this is the y variable for me right here. Treatment would be treatment, that same variable that we used here. And for x, we would be using the fitted values from this earlier result here. Okay, and then we can use summary for this matches. And these are the summaries that we have here. So we would have the difference here, that's the estimate of $6,487. So we can say that if individuals have participated in the program, their earnings are $6,487 less than if they didn't participate in the training program. So that's not a very good result, and you can see that it's statistically significant. And you can see this is the number of treated observations, 185, and this is the total number of observations that we had here. So here I have also commented out a few more models that we can do, and for the most part, if you skip some of these, we would get the defaults up here. So you could put estimate, ATT, average treatment on the treated, or average treatment effect here. So this is the correct way to do it, and this is like a t-test to do. M equals 1, meaning that each controlled observation would be used once, and this is how to resolve ties and whether or not to use replacement when you're looking for matches. So these are some of the default commands that we have there. The next thing that we can do is check the balancing property, and we can accomplish this by using match balance, and then you use treated on the X, and then you have the results from RR1 that we had here before. Number of bootstraps is 0, or you can increase that number, and data would be equal my data. And here we can look at the QQ plot, and here we would have variable 1. Remember that I defined this as age from those, the controlled and the treated observations, and then we would plot this on the on a graph. And here I have already executed the program, and I have the result here. So we would have variable 1, this is age, for the control and the treated observations, and this is like a perfect match here. So if we see that we have like treated observation that has a certain age here, we would be using from the control, we would be using age from here to here. So I'm looking at the scale, probably 1 year difference, and we see that our matches aren't as good as we get older people in the sample. So we have like one person here that's 43 years old, but we have these as matches for them. So quite a big, like up to 10 years of difference as matches. So we want those to be as close as possible to the 45-degree line in here. And the next few things that we can do is also looking at the balancing property here, which we didn't do, but okay, so we can see this is the mean before, say for the age variable, this is the mean age before matching, and this is the mean age for the control group before matching. So there's a pretty big difference. So younger people got treated. So after matching, this will be the same, of course, because we're interested in the treated group. We'll keep all of them. But look at the control group. We only kept people that now are a lot closer in age than before. So that's a good thing. We found really good matches for them. And same thing here, for education, this is for treated, and this is for the control group. And now after matching, you see how like that number from 12 got down to 10, so it's a lot closer to the 1, and so on. Okay, and then I showed you the graph. So next thing to do here is we can also do a couple more things, but I copied these from like different different codes that I compiled here. But we can also use gen match, and we can put the treatment X variable, balance matrix X, population size 10. We can then put match with different weight matrix that you're taking right here from Gen 1, and then we can do match balance, and then we could have treatment on X, data my data. You're getting the results from here, and bootstraps equals 0. So this is supposedly a good way for using genetic matching, and you can also look at some of the results here that we have for different variables. So the final thing here to do is look at this genetic matching, which is supposedly a better matching. And you can look at the match balance here, which is the same command as we had before. And this will be the results that you have before and after matching. And the final thing that you can do here is some sensitivity tests. And what you need to know here is gamma is the odds of differential assignment to treatment due to unobserved factors. So what we are varying here is what if some unobserved factors are also influencing the assignment to treatment. And here we would like to know how that would affect the estimates. So we're using these commands here, and we're using some of the previous results that we have generated up here. And if you look at the value of the estimate was this number here, and we would like to know how that would change as gamma changes. And these differences here show the sensitivity of the estimates. And you can see as gamma increases, then you would have a lot wider range for the lower and the upper bound on these. So this is all I had on propensity score matching in R. Thank you for watching.